All right, so as we solve equations, the key is to get x by itself. What's the key to solving equations, class? X by itself. Isolating the x, we say. Getting it by itself. So here's the idea. There's an equal sign. As long as an x is all by itself on this side, I'm good. I can have just x and nothing else. Anything that's with the x has got to go bye-bye, okay? So, Hayden like x, we all leaving. Him lonely. We can all be over here having a party as long as he's by himself. The x has got to be by itself. So anything with the x has got to go. All right, now, we get rid of things by doing the opposite. So if it says plus, class, we minus or negative. If it says minus or negative, we plus or positive. If it says multiply, we divide. If it says divide, we multiply. We always do the opposite of whatever it says. So for instance, if it said x plus 2 equals 3, well, the x isn't by itself. What is with the x right now, Hayden? A 2. Class, is the 3 with the x? No. The 3 is on the other side of the equal sign. The 3 is fine. The 2 is the problem. And it says plus 2. Notice this is a separate term. If it said 2x equals 3, do you see here the 2 is not a separate term from the x? It's with the x. It's multiplied by the x. So it's not actually, even if it said this, it's not a plus 2 or a positive 2. It's a multiply by 2. Do we see the difference between a positive or plus 2 and a multiply by 2? Okay? This says positive 2 or plus 2. So to get rid of plus or positive 2, class, I put negative 2. And it's gone. And now x is isolated and we're happy. But what we do to one side, class, have to do to the other side. So I can't just put a minus 2 over here. I've also got to put one over here. And I've got 3 minus 2 or 3 negative 2 gives 1. Make sense? So if I had x positive 5 is equal to negative 7, what's the only number that troubles my soul right now? The 5, the positive 5, right? That's the only thing that troubles my soul is this positive 5 or plus 5. I don't worry about the negative 7. I'm focused on this positive 5. And I'm focused on doing what with the positive 5, class? Getting rid of it. How do I get rid of a positive 5, Danielle?
You subtract 5.
Subtract 5. Or we could think of it as putting a negative 5. And in this particular problem, it's really going to help us to think of it as a negative 5, not as a minus 5. Think of it as a negative 5. Because if I put a negative 5 here, class, I also got to put a negative on the other side. Well, now I've got a negative 7, negative 5. If the signs are the same, oh, that's even up there on the poster. If the signs are the same, class,
and keep the sign.
So my x is now all by its lonesome. Here's my equal sign. By the way, keep your equal signs roughly lined up. And keep them pretty much in a line. That'll help you to see this as a wall of separation between two sides. And what do we get over here?
Negative 12.
Negative 12. Makes sense? What if I had x positive 17 is equal to 11? What is the only number that troubles me right now, Michael? The 17. I've got to get rid of it. How do I get rid of it? Negative 17 on both sides, right? What we do to one side, we have to do the other. So I'm going to put a negative 17 on both sides. You may want to put the positive in front of the 11 right here just so you see it. But the point is, here's my equal sign. The x is all by itself. It is isolated. What is positive 11, negative 17 going to give us?
Negative 6.
Negative 6, because we subtract, keep the sign of the greater absolute value. Do we see what to do when we see a plus or positive number with the x, class? Well, what if it had been a negative number? What if this was x? Negative 17 is equal to 11. Well, again, the negative 17's got to go. Glenn, how do I make a negative 17 vanish? Positive 17, when it is a separate term from the x. It's not part of the x. It's separate from the x, so I get rid of it separate from the x. Put a positive 17 on both sides. Here the inverses cancel, and just what I wanted. X is all by itself, and then here I get 28. All right, what if it said x negative 3 is equal to negative 12 EV? What's the number that troubles me? The negative 3. And how do I solve all of my troubles right now? Put a positive 3, if only life were really that easy, right? And what we do to one side? So I'm going to put a positive 3 over here as well. Boom, they cancel. My x is all that's left. Keep my equal sign, and then right here I'm going to get, when I subtract and keep the sign of the greater absolute value. Now, what if though I had a 2x equals 14? Do you see that the 2 is no longer a separate term? So putting a positive or a negative isn't going to cancel it anymore. Does that make sense? Feet down. Instead, the 2 class is up against the x. So Lexi, that means it's being multiplied. So to get rid of it, I have to divide it. And we use the fraction bar, and I just put the 2 right under it and cross it out. Of course, what we do to one side.
You have to do the other.
So I'm going to put the 2 on the other side. I keep my equal sign nice and lined up. I keep my x. It's now isolated. And here when I divide, I get 7. What if this had been a negative 14, Lexi?
It'd be negative 7.
Because the signs would be different. What if this had been a negative 2 class? Then I don't divide by 2 because it's not a 2. Let me change the problem here. Here it's not a 2 that bothers me, Aubrey. It's now a negative 2 that bothers me. But again, the negative 2 is not a separate term. It is being multiplied. So to get rid of it, I have to divide it away from both sides. I like to cancel the negative sign separately as well. You don't necessarily have to do that. And then here it's a 10 or a positive 10 being divided by negative 2. Get negative 5, right? If we had a 4x is equal to negative 16, what's the number that troubles my soul, Lexi?
The 4.
The 4. Do you ever feel like a 4 in trouble? Anyway, but we've got a 4. To get rid of the 4, because it is being, it is not a separate term, I've got to divide it away using that fraction bar. And what we do to one side.
You have to do the other.
So here I'm going to get x is equal to
4.
but the signs are different. Remember, in a division problem, if the signs are different, it's an automatic negative. So negative 4 would be our answer. What if I had x over negative 3 is equal to 7? What's the number that troubles my soul, Evie? The negative 3. Now, what is the negative 3 doing right now? It's being divided. It's not a separate term, class. It's all part of this term, but it's being divided. So to get rid of it, I should
do the inverse, negative 3 over...
Well, just in general, what's the opposite of division? Multiplication. So if it has a divided by negative 3, I should multiply by exactly what troubles my soul. Negative 3 troubles the soul. So multiplying by a negative 3 is the opposite of dividing a negative 3. Does that make sense? All right? And so when I multiply by negative 3, gone, all I'm left with is the x. But what I do to one side, so I'm also going to multiply this side by a negative 3. And of course, we know that 7 times negative 3 gives negative 21. What if I had an x over 12 is equal to 2? What's the number that troubles my soul, Glenn? The 12. And it's being divided, so I need to multiply. And what I do to one side, here a times 12 and a divided by 12, since they're opposites, are going to. So all I'm left with over here is x. And I've got my equal sign, and then 2 times 12. By the way, notice I never actually do anything to the x itself, Danielle. I leave the x. It's always whatever's with the x, right? I never actually do anything to the x. Now, sometimes we may have problems where there's a little bit of simplification to do first. Like, for instance, we might have a x plus 10 negative 12 is equal to 4. Well, here there's 2 numbers. I could get rid of them one at a time. I could get rid of a minus 12 class by putting a positive 12 on both sides. And then I could get rid of a plus 10 by putting a, but I'm too lazy for that. Instead, I'm just going to combine these 2 constant terms together, Michael, to get
negative 2.
So now it's x negative 2 equals 4. Now I only have one number to have to get rid of. One number that troubles my soul.
Negative 2.
Negative 2. So if you can combine your problems into one troubling number, that's going to help you out. I have a negative 2. You said put a
Positive 2.
And notice, because it's a separate term, I'm putting the inverse, which is addition here, or positive. Now these cancel, leaving me with x is equal to 6. There was one kind of a weird thing that came up, Danielle, and it was if we had like a fraction or something times the variable. And we said technically this fraction is being multiplied, right? It's up against the x. And just like we had here with a 4x, or a negative 2x, or a 2x, or whatever, if it's being multiplied, to get rid of something, I have to divide it. And we said technically you could divide 3/4. But we never divide fractions, class. We multiply by the reciprocal. So rather than taking time to show this step, and this, and this, and all of that nonsense, I said the easiest way to do it is just go straight to multiplying the reciprocal. So again, not that you couldn't show all the usual steps, but if you see the fraction multiplied, multiply by the reciprocal. Because as you know, the 3's cancel, The 4's cancel, and all that's left now here is an x. But what did I do to one side, Danielle?
You have to do the other.
And so here I'm also going to multiply 4/3, but my strategy tip was if this is not a fraction, make it a fraction by putting it over 1. And now we can just multiply. Now, unfortunately, nothing cancels, so I'll just multiply straight across to get what improper fraction.
20.
And the good news is, since we're in the algebra chapter, I can leave it like this. And all next year in Algebra 1, you're going to leave it like this. Now, if it really bothers you, like, no, I can't do it, I just can't do it. I gotta do 9 1/3. Okay, fine, do 9 1/3. I won't mark it wrong. But when we're in the algebra chapter, we get improper fractions. And we get to be lazy and leave them like that. And I like that. All right? Now, what if though, Hayden, I had a negative 2/5 x is equal to 4? Technically, what would I have to do? Not what are we really going to do, but technically, what do I have to do since the negative 2/5 is being multiplied?
Divided by 5/2.
No. You're making this way too hard.
Multiplied by 5/2.
Okay, hey, since it's being multiplied, normally I'd say if something's being multiplied, to get rid of it, just divide it. What would we normally divide away in this case? Negative 2/5, because that's what's with the x. Does that make sense? Normally, class, like if it's a 4, I divide a 4. If it's a negative 2, I divide a negative 2. If it's a negative 2/5, I divide a negative 2/5, right? But Hayden keeps trying to get ahead of me here. I'm not going to divide negative 2/5. Instead, Hayden, what will we do?
Multiply by 5/2.
No. What is the reciprocal of negative 2/5? No. Class?
Positive 2.
No.
Negative.
Negative 5/2. Reciprocal means you flip it, remember? What do I get if I flip this? I get negative 5/2. Does that make sense? Reciprocal doesn't mean you change a sign or anything. Reciprocal just means you flip it. And if you flip it, it's still a negative 5/2, right? So we say, get rid of a 4, divide a 4. Get rid of a negative 2, divide a negative 2. Get rid of a negative 2/5, divide a negative 2/5. But no, we don't really divide. We multiply by the reciprocal, negative 5/2. That makes sense? With the sound effects, Aubrey, right? All right, what we do to one side, class, got to do the other. So I'm also going to multiply the other side by negative 5/2. And Hayden will put the 4 over 1. Do you see what we're doing here? The sign isn't changing in a multiplication by a reciprocal. Now, what cancels here, Hayden?
The 5.
And 2 negatives together give me a, which is why we had to multiply the negative as well, so we could cancel even the negatives, because negative times negative becomes positive x, or just x. If we don't, we still have a negative, and that really annoys me. I hate negatives. So over here, we can cancel the
2 and 4.
to get,
2 and 1.
but we don't cancel the negative because there's not another negative to multiply it by. So my answer comes out to
Negative 10.
negative 10. What if I had a negative 1/7 x is equal to negative 3? What would I have to do to get the x by itself, Michael?
Multiply by negative 7 over 1.
Good. Divide by negative 1/7. No. Multiply by negative 7 over 1. Do we see we just flip it? But what we do to one side,
You should do the other.
and when I run out of room, when I multiply by negative 7 over 1 here, I guess technically put that over 1. Here, negative times negative,
Positive.
which I can now leave understood. 7 and 7,
1.
and the 1s, I mean, who cares about a 1? It's a positive 1x, but do I need to write the positive? Do I even need to write the 1? X, all by itself. And then over here, when we multiply, we get
21.
positive 21. Do we have to write the positive, class?
No.
And there's my answer. Do you feel like you understand this a little bit better now than we did yesterday? Because yesterday we seemed kind of lost. Does this help? Are there still some questions? Can you show me another one of those before we end this video segment? Because again, if you've got a question, I bet somebody watching on YouTube has a question also. Or do we feel like, no, I got it now, thank you, this helps? How many are the, I've got it now? How many are the, still a little unsure on problems like blank? Or maybe as you look at your homework on page 142, there at the bottom of the page, you're like, I struggled with this one, and as I look at it, I still don't know what I would do on this one. Any questions there? All right, you two people, if you have questions, shoot me an email, and I can give you some more one-on-one tutoring if you need more than that. All right.